This video will talk about how to determine the order with which electrons fill the orbitals or the energy levels. And there's two ways to do it. One is called the diagonal rule. And I put a little chart on the left side of the page. And you can make this chart pretty easily if you're on a quiz or a test. You just write 1s, 2s, 2p, 3s, 3p, 3d, and then put diagonal arrows to show the order in which the lowest energy to highest energy orbitals fill. Now, there are a few exceptions. However, just knowing this order will get you 95% of the way there on the elements. The other way is to look at the periodic table. So for nickel, which is our example, let's see if I can move down my, let's do this. There we go. Which is our example here. I'll do that in both ways. So for first we'll do the diagonal rule, we'll do the full configuration, then the noble gas configuration, and then I'll show you how to just shortcut this and use the periodic table. For nickel, we have to count how many electrons nickel has, which is 28. I should memorize that, but I wanted to be sure. So with 28 electrons, if we look at the diagonal rule, just as before, we're going to fill the 1s first. I'll just stick with the green here. And the s orbitals sublevel always holds 2. 2s2, 2p6, you should be getting used to these first ones. 3s2, 3p6, 4s2, 3d8.
1s2, 2s2.
So what you might notice, and we've talked a little bit about, is that if you go up to 3p6, we are up to 18 electrons, which is the same as argon. So we can shorten this by going to the previous noble gas and saying argon, and then just fill in the rest. 4s2, 3d8. And so what I did is I used the preceding noble gas to fill in up to the third shell. And this could be the second shell, the fourth shell, the fifth shell. If I look on the periodic table up here, argon is at the end of 3p. Let me change colors. Let's go purple here. So we went up to argon, and then we went after that. So the way the periodic table is organized is, if you noticed, nickel ends right here. So the last electron you put in is actually the 3d8 electron. And so all the ones that you put in a d electron for last are called the d block. Similarly, all the ones that you put in a p electron first are called the p block. And if the last one you put in is an s electron, yes, you guessed it, that is the s block. And if it happens to be an f electron, that's the last, the f block with a particularly dark marker. So if I was going to find nickel and wanted to skip all that stuff with the diagonal rule, all I need to do is find nickel on the periodic table and then go to the preceding noble gas, which is argon. And I would start with argon. And see that after argon, in the fourth row starts the 4s orbital. So I'd go argon 4s, and that holds 2. And then I would just count along the d, 4, 5, 6, 7, well, 8. We put that right here. And 3d8, because the top d shell, or d sublevel, starts in the third level. So we end up getting the same thing, argon 4s2, 3d8. Let's try one more example using the periodic table. And let's go with silicon. Silicon, let's see if I can get that on here. Just going to write it up a little bit higher so we can see the periodic table. Silicon is element number 14. So if you look on your periodic table, it is right here. Definitely want to have your periodic table in front of you. Mine's pretty far away, so when I double checked it, I had to squint my eyes. So the preceding noble gas for silicon is neon. So I'm going to write it up here just because it'll be easier to see. Neon has 10 electrons. So now I'm going to do the next electrons after that. So neon was up here. Scroll down a little bit. And then after neon, it looks like the next orbital is 3s. So we'll say 3s2. And then there's no d electrons in this spot. So there's no 2d. So we skip all the way over to 3p2. And that is silicon's noble gas configuration, just going straight off the periodic table. For valence electrons, silicon, the outermost s and p electrons are in the third shell. And if we look back at nickel, the outermost s and p electrons are just the 4s2 electrons right here. So 2 valence electrons for nickel, 4 for silicon. And you might notice something about where things line up in their vertical columns based on their valence electrons for the periodic table.